All right, welcome back to the session. So in this session, we're going to be discussing interval sets. Yeah, so this is a very simple topic and a very short topic. Okay, actually, I was supposed to teach real numbers before this, but seeing to it that it's very short and it can be covered in a day, I want to first start with this, and then, but in the process of teaching this, I'm going to introduce real number. In short, I'm just going to tell you about real numbers and what they are. And then we'll discuss this because real numbers are applicable in interval sets. And then from this topic, we're going to cover binary operations, and then we also need to look at sets of numbers and how to convert certain numbers from maybe rational to converting numbers from decimals to fractions, yes, and to also show that certain numbers are rational numbers and to prove that certain numbers are not rational numbers. All right, so we're going to do that after this topic. So this one is a very short topic, and let's see what we can do. So these are my contacts on the screen. If you wish to contact me for any reasons, feel free to use these contacts to reach me. Okay, so interval notation of sets. Right. So the most important thing that you need to understand about the interval notation is that whenever you're dealing with intervals, we deal with real numbers. So anytime you've been given any question based on interval, just know that all the numbers that you are going to be dealing with are what? Are real numbers. And what are real numbers? So what are real numbers? So real numbers are simply just all numbers excluding when you put all numbers together, then you exclude complex numbers or imaginary numbers, then you call that set as a set of real numbers. Or in other words, you can say when you add the set of rational numbers and irrational numbers. So when you add the sets of rational numbers and irrational numbers, you come up with a set known as the set of what? A set of real numbers. So when you add rational numbers and irrational numbers, you come up with a set known as the set of real numbers. And then what are rational numbers? So rational numbers are simply just numbers that can be expressed in the form A over B. So any number that is able or that you can express in a fraction form is called a rational number. And then any number that you cannot express in a fraction form is called an irrational number. So examples of irrational numbers are the square root of 2, the square root of 3, the square root of 5, the square root of 6. So we are going to see how to prove that these numbers are irrational numbers in the next session that we're going to have. Yeah, so for today, you just need to know that irrational numbers are numbers that cannot be expressed in the form A over B. Even pi is also an irrational number. You can't express this in a fraction. And then rational numbers are simply just numbers that can be expressed in the form A over B. So when you add the set of rational numbers and irrational numbers, the resulting set is known as the set of real numbers. All right. So let's now quickly move on to interval notations, since we have known what rational numbers are. What real numbers are. So let's see how these interval sets are written. So when you have anything like A, comma B in these kinds of brackets, so these brackets are known as open brackets. So these brackets are known as open brackets, and then this implies that we're talking about numbers that are between A and B. So we're talking about numbers that are between A and B, but A and B are not part of the set. So this set is simply just describing numbers between, it's simply describing real numbers between A and B, excluding A and B. So in this set, we can say A and B are not members of what? If this is set A, are not members of set A. So we're talking about numbers between A and B, but A and B are not part of what? The set A. So they are not members of set A. So what if you have something like this? So these square brackets are known as closed brackets. So this means that we're talking about numbers from, so I'll say from A to B. This one was between, so this one was between A and B, but this one is from A to B. What this means is that A and B are members of what? The set B. So A and B are part of the set if you have these kinds of brackets on them. Then what if you have something like this? When you have something like this, you have open at A and then it is closed at B. This implies that A, we're talking about numbers between A and B, of course, but A is not part of the set because it's open. This set is open at A. So A is not part of the set. B is part of the set because B is part of the set because okay. So when I'm teaching, please, you should always be remembering to mute yourselves. You only unmute yourself when you want to ask a question. Okay, so this is what I'm trying to talk about. So I was saying A is part of the set, B is not part of the set. And we're also talking about numbers between A and B. Between A and B, but B is part of our set and then A is not part of the set. So this is very important. And what you should know is that all interval sets are what? Are infinite sets. All interval sets are infinite sets. You can't manage to count, if for instance, we have a set A as a 1, 3, you can't manage to count the number of the numbers that are between 1 and 3. No matter how good you are at mathematics, you can't manage to count them because between 1 and 3, you have 1.0000000, a lot of zeros, and then you just put a 1 at the end like that. Then you also have 0.000000111. So you can't manage. You have a lot of numbers between 1 and 3. So that's why we consider them to be infinite sets. So all intervals are infinite sets. So what you do, all right, okay, let's move on to the next one. I wanted to start solving a certain question, but I've just remembered that there are examples at the end of the slide. So we have
Masa, sorry.
Okay.
On set C, between A and B, which one is not part of the set?
B is part of the set. A is not part of the set.
Or where there is open, it means it's not part of the set.
Yes, it means that it's not part of the set.
Okay.
Then we have D there. So set D, what if we have A and then comma B, open at B. It means that A is part of the set here, B is not part of the set. That's what this means. And then the other thing you have to know is that when you are dealing with interval notations, every time you have an infinite symbol, either positive or negative infinity, the sign or the bracket that is supposed to be there is always open. So for instance, if you have from negative infinity up to a certain number, maybe 2, means that the bracket that you are always supposed to put on an infinite symbol is the open bracket. So whether it's positive or negative infinity, you still have to put an open bracket. So the infinite symbol always carries an open bracket. Yeah, so this doesn't exist, because infinite means that you keep on going, and this bracket tells you that you have to end at a certain number. So they don't work together, in short. So the infinite symbol is always moving with the open bracket. So this is what it means. All right, so now let us see how we can present this on the set of, rather on the number line, on a real line. How do we present this on the real line? So this is very simple. So I'm just going to show you very quickly. Okay, so the first one here, the first one there, the way you show it on the number line is like this. So you have the number line there, then you have your A there, you have your B there. So since it's open on both ends, you can just draw open circles on A and B, and then you connect the two circles. Yeah, so what I've just done is that, okay, we'll be learning on Monday and Saturday, and then Wednesday we'll be doing tutorial sheet questions. Yeah, so on Wednesday we'll always be doing tutorial sheet questions. All right, so this is what we have. I don't know, is it Tuesday or Wednesday? It should be Tuesday when we meet for math. Like, I have to check my timetable. Okay, so for the closed, the number line is going to be like this. So you have there, and there you have A there and B there. And then since it's closed, you're going to shade the dot like that. Even there I shade it. And then you connect the two dots. But for some books, instead of writing open circles, they prefer writing something like this. They'll show that same bracket, that same open bracket. They will write something like this. It's still the same. And then for closed circles, instead of showing closed circles, they'll put that kind of bracket there. You will still be marked correct. So whether you shade the circles and you leave unshaded circles on open brackets, you still be marked correct depending on the on what your lecturer wants. Yeah. So you still be given full marks. So for this one here, you're going to have something like this. You have A there, you have B there. So it's open at A and closed at B. So it's open at A and closed at B. You join the two lines. I mean the two circles. For this one, it's open at B, closed at A. So it's closed at A and open at B. So if you want, you can use circles, or if you want, you can use the brackets. You still be marked correct. So since it's closed at A, you write like this, and it's open at B, you write it like that. So that's what you're supposed to do. Okay, so for the infinite, this is how you show it. For the infinite, so from negative infinity to 2 means that you're going to write your 2 there. Then negative infinity, you're just going to draw an arrow like that, which goes to the negative infinity. And since it's closed at 2, you can just draw a circle there and shade it. Since it's closed, it's open, you leave it open. You leave the circle open. Then for this one, you also do the same. So for this one, yeah, so for this one, let me just put a 0 there. So for this one, we have 2 there, and it's closed at 2, so we can use these brackets if you want, and then you show that it's going to be going to the positive infinity, like that. So it's as simple as this. So I was saying intervals are very simple. Yeah, so this is a very simple topic. Right, so, okay, so we proceed. Let's look at some of the examples. So I think this is what I was explaining, and I've explained almost everything here. I think everything has been explained. Okay, so let's look at this example. So the example is let U be equal to, so this is our universal set. So the universal set has been given to be U is equal to open at -7 and then closed at what? At 10. Be the universal set, and then the set A has been given, the set B has been given as well from -2 to 5. So when you look at set A there, we know that 3 and 7 are part of the set. When you look at set B, -2 and 5 are not part of the set. When you look at C, -6 is not part of the set, 10 is part of the set. And then they're asking us to find the following and present each of them on the real line. So this is very simple. This is very simple. Let's see what we can do. So let's first find A intersection B. So A intersection B. So I'm going to show you two methods. The first method will be the use of the number line, which is the simplest method. And then the second method is just inspection method. So inspection method, by inspection, you can simply just write the final answer there without even drawing the number line. And then at the end, after writing the final answer, then you draw the number line. But for using the number line, you first draw the number line, and then after drawing the number line, which will help you to find the answer, you find the final solution, and then after finding the solution, you draw the actual number line which they want you to draw now. So you have to show two number lines if you are using if you're using the first method I'm going to show you. So the first method, which is we're trying to find A intersection B. So I'll first draw the number line. So the number line, so this number line, I'm just going to put important numbers since I've been given set A and set B. So I'll only put numbers that are in set A and set B. So in set A, I have -3 and 7. So I have -3 and what? And 7. And then, okay, let me just draw it a bit down here. So I have -3 and what? And 7. And then for set B, there is what? Set B, we have -2 and 5. So I'm going to put -2 there and what? And 5. So after drawing this, I can now include the brackets now to draw the lines to show the sets. So the first set is -3 and 7, so it's closed at both ends. So it's closed at both ends. So it's closed there. It's also closed there. So I'm going to join the line, the two dots. And then the second set there, it's open on both ends. So it's open there. It's also open there. And I'm going to join the two sets. So now the point at which these two sets are meeting is the one that we're calling our intersection. So I'm going to shade the region where these two lines are meeting. And the region is simply just this part here. So this is the intersection, since we have common elements here. So A intersection B is equal to, so it's going to start from where? From -2, because this is where our shading is starting from -2. And since it's open at -2, the bracket there will still be open. Then we say comma, and it's going to end at what? At -5. And it's also open at -5, so the bracket there will be open. So our A intersection B is simply just -2, 5. So to draw this on the number line, we now have to draw the final number line, which is going to be, so I'm going to show a few numbers from this side. So these are the numbers that I'm going to show. So it's ranging from what? From 2, and it's open at 2, up to what? Up to 5. So this is my A intersection B. Do we have any questions before I proceed?
Yeah, sorry, but I didn't understand it in our own Mwandi.
Okay.
Yeah.
Okay. The session is being recorded. So for this question, you just have to come and watch the recorded session, but let me explain this one and this one. Yeah, so in case you don't understand even the second part, then I'll know what to do. But for now, let me explain this one and this one. Then we'll see if you still have questions, that's when I'll go back to this one to explain. Okay. So let us look at A complement intersection B complement. So this one, if you want, what you can first do, you can first simplify this expression. So A complement intersection B complement, using De Morgan's, we can simplify this to be what? A, the sign in between will change to be union. B, and then we open and close the brackets there, the complement will be outside. So what this means is that we have to find A union B, and then after finding A union B, we have to find the complement of that. Or the best way, you can simply just draw the two sets on the real line, and then shade where the lines are going to be meeting. That is the intersection. So I'm going to draw the real line there. So I'm going to put the numbers which are important. So the numbers important here, since I'm dealing with set A and set B, so I'll just get the numbers from set A and set B. So the numbers from set A, we have -3 and 7. So I'm going to put -3 there and what? And 7 there. And then the numbers in set B, we have -2 and -5. So I'm going to put -2 and what? And 5. So I'm going to put the two sets there. So if I put the two sets, the first set that I have is A. So which one is A? A is simply just this one, which is from -3 and it's closed on both ends to 7. So it's closed on both ends. And then the other set is set B. Set B is simply just -2 and 5. And it's open on both ends. So we have -2 and what? And 5. And it's open. So this is what we have. Now, this is A, this is A on top, and down there, this is B. But we're trying to look for A complement and B complement. So what we have found right now is A and B. This is what we have drawn. So now, which one is A complement? So if this one is A, our A complement will be any number that is outside this number line. So let me extend this up to the universal set. So the universal set, the last number on the universal set is what? Is 10. So I'm going to put 10 there. And then the last number on the left there in the universal set is what? Is -7. So I'll put -7 there. So to find the intersection, the complement. So if this line represents set A, So set A complement will be anything that is outside the line. So anything that is outside the line is going to be called A complement. So A complement is anything that is this side, even this side. Anything that is outside this line for set A is called A complement. So this is A complement. This is also A complement. So let us also find what? B complement. So B complement will be anything that is outside the set B. The set B is simply just this one that we have. So set B is this one here. So B complement will be anything that is outside B. So anything that is outside B is simply just this one here. So B complement is this one. So this is our B complement. This is also our B complement. So now, what are we supposed to put here? Is it supposed to be closed or open? We follow what we have in the universal set there. So it's open. So there we leave it open. Even there we leave it open. So at 10, it's closed. So we close there. Even there we close. So now we're trying to find the common elements between the complements. So between A complement and B complement, which parts are common? So where the complements are meeting, so this is B complement, even this one is B complement. So where the complements are meeting, the two lines for the complements are meeting, that's where our intersection lies. So this part, this is where we're having the two lines for the intersection meeting. And then this side also, that is where we're having the two lines for intersection meeting, where the yellow lines are meeting. So this part where we have the yellow lines meeting, those are the parts that we are getting as our complements. Hence, A complement intersection B complement will therefore be equal to what? So we get the first number here that we have is -7, and it's open at -7. So we say -7, and it's open at -7. And then the last number that we have here is what? Is -3. But -3, the closed region of -3 belongs to what? To A, meaning our A complement is going to have -3, but it will be open because this shaded part is part of what? 3. We're saying 3 is part of set A, meaning in the A complement, 3 is not supposed to be there. This is why we have opened at 3. And then we also have another set, which is this side. So this set, which is this side, we also have to write it there. So write it there, and it's going to be, so we're starting from where? From 7. But 7, if you look at 7 there, 7 is part of set A. So since it's part of set A, it means that it's not going to be part of our complement. So we are opening. The reason why I've put this open bracket is because we know that 7 is not going to be part of the complement. And hence, we're going to say 7. We're going to write 7 like that. And then it's going to be open. And then at 10 there, we just get what is there. So we say comma 10, and it's closed at 10. So we close at 10. And then the addition of two sets, remember what I said? Addition of two sets is what? Is union. So you add the two sets by putting the union symbol in between. So this is how simple it is. The other way you can solve this one is by using De Morgan's. So let me quickly run through the same question, but using De Morgan's. So using De Morgan's, you're going to have A complement intersection B complement, and this is equal to A union B complement. So what you have to do is to find A union B. A union B simply means you're adding these two sets, A and B. So when you add these two sets, you have set A there. So we have set A from -3 to 7. This is our set A. And then we also have set B from -2 to 5. So addition of two sets, it means that we are going to add this set. When we add this set, we add it to this set. And when we add the two sets, the resulting set, which is what is inside there. The resulting set will be, so our A union B will therefore be what? From -3 to 7. So when you add the two sets, you just get -3, and it's going to be closed there to 7, closed there. So now, to get the complement of this set, because we're trying to find the complement of this set, how do we get the complement of that? So to get the complement of that, we simply just get the numbers that are outside this. This whole part is the union. So now to get the complement, we're just getting the numbers that are outside the union set. So the complement will therefore be, so we're starting from what? From -3. Since -3 is part of A union B, we're trying to look for the complement. Since -3 is part of A union B, it means that it's not going to be part of our complement. So we open at -3, and then we say comma. The last number that we have in the universal set when we're going towards the negative is what? -7. And oh, sorry, hence I was supposed to start with -7, not -3. So I was supposed to start with -7, comma, -3, and it's open at -3. And then we say union, open brackets, and then this side, the first number that we have is 7, but because it was, because 7 is part of A union B here, meaning it will not be part of A union B complement. So I'm going to open at 7, then I'll say comma. The last number that we have is 10 in the union in the universal set. The last number that we have is 10, and it's closed, so we close it. You can see that we've gotten the same answer. Okay. So there are two ways. I showed you the first one, and this is the second one. So what you should be doing if you want to be understanding what we are learning, after class, find time to go through the video. That's why I record the sessions. You go through the video bit by bit. Where you don't understand, you repeat the video until you understand. So we move on to the last part of the question. So the last part of the question is A union B complement. We have A union B complement. So the first thing that is important is to write the universal set. So the universal set is from -7 to what? To 10. And then the other thing is to put in the important sets that the important sets that in the question. So we have A and B in the question. So set A is from -3 to what? To 7, and it's closed on both ends. And then set B is -2 to 5. So from -2 to what? To 5, and it's open on both. So let me first join A. So this one is open on both ends. So now we're trying to find the union of A, which is this one, and B complement. So B complement is anything that is outside A. So we have A, and B complement will be from there. B complement, since we have an open, or since 5 is not part of set B, meaning it's going to be part of the complement. So for the complement, I'm going to shade 5, and then up to what? Up to 10. And then the last number there in the universal set is 10, and it's shaded there, it's closed. So this is my B complement. And then here we also don't have 2 in the in set B. We don't have 2 in set B, meaning it's going to be, we don't have -2 in set B, meaning it's going to be part of the complement. So I'll shade there, and then I'll go up to 7. And then when you look at 7, 7 is open in the universal set, so we leave it open. So now we're trying to add the two sets, A and B complement. So I'm trying to add A, set A, and what? And B complement. So when you add set A and B complement, what are we going to have? So when we combine set A and B complement, what are we going to have? So let's see what we're going to have. So we're combining this set here, and so this is B complement, is also B complement. So when you combine the two sets, you're just going to get, so A union B complement will therefore just be equal to, you get the first letter and the last, the first number and the last number that you have there. So the first number is -7, and then the last number is 10 there. So you just get what you have as your first and your last number. So it has just given us the universal set. All right, so I think the next time we'll come and start from the next example, which is this one, and then we'll see how we're going to proceed. All right, see you in the next session that we're going to have. I'll send the recorded sessions to the group.
Okay, thank you.